Capacitor is simply a device that stores what? Electric charges and what? Energy. Please take note. A capacitor is a device that stores what? Electric charges and energy. But what is a capacitance? Very important for your test. What's a capacitance? If you think of the capacitor to store charges, you will be given half mark. But look at this now. Capacitance C is actually how a capacitor can store charge. How big? So the ability of it to store charges. But normally, how do they store charge? They store charge as a result of what? The potential difference that is applied at the end of it. It is the PD that produces the charges that are stored in the capacitor. So what you see is this. Charge Q is always given as what? C times V. If Q is C times V, this C is what? The capacitance. So we can now say that our capacitance C is what? Q over V. So if someone asks you now, define capacitance as a physics, what you say is that what? Capacitance is the ratio of what? Of charge per what? Potential difference. Capacitance is the what? The ratio of charge per what? Unit potential difference. Q over V. Now what's the unit for charge? Charge is in what? Coulombs. Over what is the unit for potential difference? Volts. So you can say that capacitance C is what? Coulombs per what? Volt. Or 1 coulomb per volt is equivalent to what? Farad. Take note. Farad. So capacitance is in farad, but it can be asked, 1 farad is equivalent to what? The answer is what? 1 coulomb per 1 volt. 1 coulomb per 1 volt. Note is the arrangement of these capacitors. Arrangement of capacitors. Capacitor can be arranged in what? Series or in what? Parallel. Arranged in what? Series or parallel. Now let's look at this now. If you check a capacitor symbol, the length of the plates are what? Are equal compared to with something like this. This is what? A cell or probably a battery when connected. So you can see one is longer than one. This one is not a capacitor. But when you see the plate drawn the cell, it is what? Capacitor. So if I call this C1, call this C2, and call this C3. This arrangement is series. Capacitors are in series when the same charge flows across each. So if you have this arrangement like this is when they are in what? Series. Anytime you notice that the same charge flows across each capacitor, we now say that the arrangement is in what? Series arrangement. So this is series. Now if they ask you now, what will be the equivalent capacitance when they are in series? At any point in time, when capacitors are in series, the equivalent capacitance will be given as 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3. This you should know. I'm not going to dwell on this. You know this already. This is for series, the same charge. If it's the same charge, what happens to the voltage? Will the voltage be the same? When capacitors are in series, the charges are the same, but the voltage are what? Different. The voltage differs. Not the same voltage. So now, I established two things. Same charge, different voltage for series arrangement of capacitors. Let's look at when they are in parallel. Capacitors in parallel. From there, we'll now solve the problem you should note. Capacitors in parallel. Look at when capacitors are said to be in parallel. You have this. This arrangement is what? Parallel arrangement. When capacitors are in parallel, see what happens. The charges are different, but the voltage are the same. Take note. Different charges, same voltage. Why is it different charges? Let's assume a charge is coming in from this branch. When this charge gets to this point, that point is a junction. A junction is a point in a circuit that links 3 or 2 wires together, or 3 components together. So when it gets to this point, what happens? It will split. The charge, if this is Q that is coming in, Q total. When it gets to this junction, some will go here, Q1, some will enter here, Q2, and some will go here, Q3. So you see that the charge that was coming in has splitted. So no longer Q total that is going to be found here. Instead, it will split into this, and that. Then let's ask a question. The greater the capacitance, what happens to the charge? Is it the greater the capacitance, the greater the charge stored? Or the greater the capacitance, the smaller the charge stored? The greater the capacitance, the greater the charge stored. Capacitance is just like having your GP tank in your house. And you have a tank that is what? 500 liters. And you have one that is what? 1,000 liters. Between the 500 liters and the 1,000 liters, which one will store more water? 1,000 liters. So we talk about that 1,000 liters having a greater capacity. That's capacity. So it stores more volume of water than the one that is 500 liters. The same thing is applicable to capacitance. The greater the capacitor, which is like capacity, the greater the charges stored. The smaller the charges stored. So one thing you should just note, all those things are not too necessary for now. What you need to know is, when they are in what? In series, how do you find the equivalent? So here, the equivalent capacitance C total will be given as you add them up. Whenever they are in parallel, you know what? You add them up. That will be what? C1, C2 plus what? That's how you solve when they are in parallel. In parallel, you add. In series, you take the reciprocal. And I was trying to make it simpler. Whenever 2 capacitors are in series, how do you find the equivalent capacitance? Product over sum. Abi, if you're not in my class earlier, let me look at this now. To a voltage source. If this is C1, this is C2, and this is V total. See what happens. If a voltage comes from here, this voltage will produce a charge Q. The charge that's coming out from this battery is the total charge. This charge will now flow across this. These are all wires or conductors. The charge will just go like that, and all the charge will enter here. The same charge will enter here and flow around the circuit. So the same charge, but what? Different potential difference. So now, whenever you have 2 capacitors like this in series, to find C total, instead of saying 1 over C1 plus 1 over C2, you just use what? You use products. All over what? Sum. What do I mean by that? Product means C1 times what? C2. Sum means C1 plus C2. This is only possible when the capacitors are only what? 2. And in what? In series. If it is 3, you will not go and say C1 times C2 times C3. All over C1 plus C2 plus C3. Mr. C did not tell you this one. This cannot be possible. If it is more than 2, you will go with your normal. Even though it is 5, you use this. If it is 7, but whenever it is just 2, you can just use product over sum. I call this 3 microfarad, call this 6 microfarad, call this 2 microfarad, and call this 4 microfarad. Don't forget that anytime you talk about micro means what? 10 raised power minus 6. Is that okay? Now, if I draw this circuit like this, the way it is now, these capacitors, are they in series or in parallel? Series. The way they are now, are they in series or in parallel? Series. This is series. All of them are in series, the way it is now. Because wherever a charge will come from, which normally this circuit is not an active circuit, but if you happen to be like this, and a charge is just flowing, all the charge will enter, will not be flowing around like that. But look at this, the proper circuit. And I have my branch. Now, are these capacitors now still in series? No. So they ask you now, the question is, find the equivalent, find the effective capacitance. If you don't call it effective capacitance, you call it total capacitance, or you call it what? Equivalent capacitance. Find the effective capacitance. To find effective capacitance, what do you do? This one and this one, are they in series or in parallel? These are in series. Are they established? What about this one and this one? So what you do is to first play with these two in series. Play with these two in series. You will now turn to one. The circuit will reduce before you now find the total capacitance. Can we solve? Okay, someone should do it. Okay. Use what? Product over sum. So I can find my probably effective of these two first. I can call the effective CA. I can call it CA. And my CA will be what? Product over sum. That will be 3 times 6. All over what? 3 plus 6. Is that true? When I say product over sum. Which one is minus? At this point, just using the all of them are in microfarad. At the end, your answer will still be in what? In microfarad. Don't include it in the calculation for now. I said you have to find the charge or the voltage. So our CA will now be, what is 3 times 6? 18. What is 3 plus 6? So what is 18 over 2? Sorry, 18 over 9. So the answer is now 2 microfarad. The minus has come back. Young man. The minus has come back, according to you. Not really minus, the smaller way of representing farad. So that's 2 microfarad. You have found your CA. We can also come to this man and call it CB. Let's find CB. Our CB will be also what? Product over sum. That will be what? 2 times 4. All over 2 plus 4. What would that be? 8 over 6. What's the answer? 1.33 microfarad. Now see how the thing will now look like. The thing will now look like you are going to have this and this. This is the hand, this is the hand, this is now your what? Your CA. Abi? That's your CA, this one. Well, this is your what? CB. What is CA? 2. So this one is now going to be 2 microfarad. What's your CB? 1.33 microfarad. Now you ask yourself, this man and this man, are they in series or in parallel? So what is now the effective capacitance? You add them up. So therefore, our C total or C effective will now be given us. Since 2 of them are in parallel, you add, that will be what? CA plus CB. This means that our C total will be, what is CA? 2 plus 1 plus 1.33. That will give you what? 3.33 microfarad. Leave it there. That is how to reduce that. Any unbeliever? Please look at it very well. If you don't understand, you ask question.